Hey guys, we continue doing true bearings, the subtopic from trigonometry, and we're considering several best examples that you might meet on your exams. This is GCSE and iGCSE Higher Maths, so make sure you watch all the previous video in order to understand what we're doing today. So we're gonna go to the next problem before we consider the first problem. Actually, it was good because we're practicing with different bearings on different points in the triangle. That was actually typical exam style questions. All right, we're gonna go to another problem. So grab your pen, grab your notes or a piece of paper and try to work out by your own. Okay, so we're gonna do right now with explanations. So what we have a boat that departs from port P. So that's why we have the port P first of all. Let's set up this point as point P. Okay, that's too big for now. Okay, and also let's choose that one, appropriate. Okay, so let's set up the initial point P where actually the boat departs, and first it sails on the 150 course for 400 kilometers. What it means that we need to set up nose direction, just right there. Okay, this is nose direction, and from here we need to also set up direction where the boat goes. Let's say 150, let it be right there. Okay, let it be 400 kilometers length. And this is the final point of destination P1. Okay, so the angle 150 degrees is going to be bearing. So that's why we set up this angle as 150 degrees from the point P that we have here. Okay, that's the point P. And 150 degrees as the bearings. So P1 from P is going to be bearings. Okay, next, it changed direction at the point P1, so that 240 course has a new course for the boat and sails versus 300 kilometers to the final destination P2. So that's why, let's say from north direction, we need to set up, okay, let it be north. So in both cases, there's going to be north direction here and here. So we turn around in clockwise by 240, and so by my eye I can establish that this course is going to be somewhere here. Okay, I understand that actually diagram might not be drawn to scale, so it doesn't matter. However, I try to do this. So let me see. Yeah, I think so. It's gonna be all right. Maybe like narrow. Okay, let it be so. Okay, so that's the final destination point P2. Okay, and 240 degrees is the angle as the bearings from north direction in clockwise, so 240 degrees. Okay, we set up bearings, we set up courses. Now we need to set up distances. So let's set up distances here. So the first is 400 kilometers and the next is 300 kilometers. It's right there. Okay, so what we're gonna do first, the first question is about the shortest distance to the port P after the boat has covered 700 kilometers in total. So in total means those 40, so it went to P1 and then after the turn it covered another 300, so until it reached point P2. So up to the point P2 it covered in total 700 kilometers. So that's why the shortest route is going to be the route from point P2, final point of destination, so to the point P. This is going to be actually the absolute value for displacement. So we can say that this is going to be displacement. So we can mark as P P2 absolute. So this means absolute length of the vector or magnitude. Okay, so what we're gonna do, we're gonna drop this vector here. Let it be a red one or a pink one, that's okay. So, and this is gonna be the final displacement, okay? So we can mark as D. So we need to find this D. So let's say this is D. We set up D here, kilometers. Okay, how to work it out? We have the triangle because obviously you need to use triangle P, P1, P2. But we need to know some angle, at least, so one angle is enough in order to solve this problem. This triangle is not, so because the diagram drawn not to scale is actually your drawing, this should be your drawing, we don't know this angle, but it seems to me it's 90 degrees, okay? However, we need to figure out clearly. If it's 90 degrees, there is no problem, we can calculate using Pythagoras because we're given two legs and we can establish the value for D if angle P in the triangle P1 is going to be a right angle. So in any way, we need to calculate the angle. So let's set up as X this angle and we need to calculate it. All right, what we're going to do, we're going to use, I think, central angle 360. So look guys, if you use again the theorem about two parallel lines, I'll set up greenish line, maybe dashed lines, okay? Let me see, okay, let it be greenish one. Oh, okay, not greenish one. Let it be purple one. So lines that parallel to the north direction going through P1 and through point P, maybe. Oops. More precisely, right, like this, okay? More precise like this. So we set up two parallel lines and we know that in total this small angle 150 together with this small angle is going to be 180. So that's the open angle. So that's why obviously this angle is 30 degrees. So we can say that this angle is 30 degrees. However, we need to find the alternate angle here. So this angle obviously right there. So this angle also 30 degrees using the theorem about alternate angles. So let's see, 30 plus the bearings 240 and plus angle X should form 360 because this is the central angle around the point P1. So we can say that 30 plus 240 and plus angle X should form 360 degrees. So we can say that this will be equal to 360 degrees. From where we know this is 270 and we can figure out X as the difference 360 minus 270, it's 90 degrees. So hopefully this angle is 90 degrees and we have right angle right here, okay? So this angle is the right one. If we use this fact as 90 degrees angle, we can figure out using Pythagoras, no problem. So d squared, so let's have a look there. So d squared is going to be a result of 400 squared and another 300 squared as two legs. So from where d is going to be the square root of what we recently calculated, but actually I'm going to use the square root of what you have here. So the result is going to be, let me see, 400 squared and we add 300 also squared and taking the square root of all. We've got 500 kilometers. So now we know that distance d is going to be 500 kilometers and that's the answer. So d is going to be 500 kilometers. And this is displacement from the original position P up to P2. And actually, this is the magnitude of displacement, because displacement, it's a vector. So let's have a look at B. You need to figure out the bearings of the point P from P1. So point P from P1, so that's why we set up north direction and the point P1, because we need to define the bearings from P1. So that's why we set up this north direction in the starting point, and then started turning in a clockwise direction until we reach the segment PP1. Okay? So in total we have this 240 and extra angle that we calculated, which is 90 degrees. So 240 plus 90 degrees is going to be bearings. 240 plus 90 degrees. That's going to be bearing P from P1. So in total we have 330 degrees, and that's the answer for part B. So question C. Let's have a look at the question C. We need to find bearings of P2 from P. So P2 is right there from the, P2 is right there from the point P. So that's why we set up north direction and the point P right there, and we turn until we reach this red displacement, which is 500 kilometers in length. So what we're going to do, we need to find the bearings. So the bearings will represent 150 degrees plus this small angle. Let's set up as Y. So in our case, the bearing of P2 from P will represent 150 degrees plus angle, small angle Y within triangle. Okay, so we need to find angle Y within triangle, and that's the primary goal. We're not going to use any other points except for we actually use trigonometry here in full. So we have angle Y unknown, and we have two legs. What we're going to do in right angle triangle, we can use tangent rule. So angle Y can be found through the tangent. So that's why we will use tangent of angle Y. We will use 300 as the opposite leg, because this is the opposite leg to the angle Y, to adjacent, which is actually 400. So we divide that, and it will cancel, we'll get 3/4. Now, in order to calculate angle Y, we need to use tan minus 1, inverse function of 3/4. Okay, use calculator and just immediately do it. Remember, on the calculator, you need to use the button tan minus 1 or arctangent of 3/4. What I've got 36 and 87. So angle Y is around 36 and 87 degrees. Okay, we set up this angle, and we found finally the angle Y is 36.87. So that's why if we plug in here, we can calculate that in total we have around, so that's to 2 decimal place, by the way. So we will get 186.87 degrees. So that's the answer to the question C. All right. And the last one, the bearing P from P2. So bearing P from P2. Okay. What we're going to do, we're going to set the north direction to the point P2. So we're going to do this right now. Let's have an arrow. So from there, that's point where we stand. This is north direction right now. So north. And bearing P. So we need to turn in this way until we reach this red segment. That's our final bearing that we are going to find. Okay, is that right? Yeah, I think so. So in this case, let's see. This is the bearing and the angle that we're looking for. Okay, so P2 is the starting point, P is the ending. Okay, so let's have a look. What do we have? Let me see. We have 100, yes. If we use two parallel lines and the second line, we actually can arrange the angle 150 plus y, right, in total. So because we actually found the bearings P2 from P, okay? So that's why now we can calculate that. So let's have a look at the angle 150 plus the small angle y that we recently found, 36.87. So in total, up to the red segment is going to be bearings P2 from P. So from P, yeah, P2 from P. But this question asks us about the vice versa, so this bearing. So that's why we can set up this angle, which is 186.87. So right there, using the property of two parallel lines here and here, and alternate angles. So this angle 186.87 is going to be the same as this angle. So I mark as red one. So this part, okay? We consider this angle. So this angle is going to be angle 186.87 degrees. So on top of that, we have another part which is 180 degrees, okay? So because it's open angle up to here, so the black part. So one more time, so here's the black part. Okay, so this angle is 180. So in total, we have the bearings 180 plus 186 in total. And what we get actually, ooh, let me see. Look, that's actually what I want to explain you guys. 180 degrees plus 186.87 will give you angle more than 360. Let's have a look. 180 plus 186.87 will get 366.87. So what it means? It means that the actual bearings, if we made a full circle plus extra, the actual bearings is going to be only 6.87. You know why it happens? It happens because simply this red line and this point P2 should obviously be somewhere here. Okay? So I try to explain you. So the actual bearings and the actual result is going to be 6.87. And now I'm going to explain right now. So what I'm going to do, I'm going to just, I think, I'll just add, okay, new, or just right there. Yeah, that's okay. So right there, I just diminished that picture and all findings that we've done, okay? Just diminish that. And make sure that you understand what I'm saying right now. So in contrast, the actual picture using the proper roots should look like this. So from point P, we'll go first here. So that's why this angle maybe I draw not to scale. That's why it happens. Then we go here, okay? And then we can set up displacement from point P to right here to the final point P2. Okay, so that's point P, that's P1, and that's P2. Okay, I just simply made a little turn of our root system. And look what happens actually. We're looking for the bearings right now. Yes, so we're looking for the bearings P from P2. P from P2. If we set up now the north direction right there, the actual bearing is going to be this very, very small angle, which is actually, we already calculated 6.86. In this case, it's a right bearings, and this is what it's supposed to be. If we use actually more proper, more accurate drawings than me, you actually should get this result. But however, even if it's not drawn to scale and if it's not like really accurate, you understand if you went over 360, the actual bearings is only 6.87, because your bearings can only be within 360. So bearings, or any bearing, is limited to 0 degrees and up to 360. It cannot exceed. If you exceed, actually, it means that your picture not drawn to scale and not drawn accurately. Okay, let's have a look how to get from here this angle. So pretty easy. We actually can repeat our findings. So this is, let's say, north direction, and change the color. Okay, let's have a look over there. So, and here, so we used two parallel lines. We need to define this small angle x, or let's say maybe another one. Let's say theta. Bearings for the part D, theta. And we should arrive to 6.87. Let's have a look. So this angle is 150, all right? So what it means that angle theta is going to be there, a small angle. So angle theta, using two parallel lines and alternate angles. So this part is going to be 30 degrees, as you remember, because 150 plus this small part should form 180 degrees. So this 30 degrees. So we've got 150 plus 30, okay? And 30 plus theta in total, theta plus 30, should give us the angle within triangle. So basically angle Y. And angle Y, as we calculated, it's 36.87. So that's why we can write that. What should we have? We should have angle Y, which is 36.87. So from where angle theta is basically the difference, 36.87 minus 30, and we got 6.87 degrees. So that's the same result as we did here. So that detail is very significant, guys. If you drop the picture and if it's not really accurate, so that you probably messed up with proper angles, so you'll get some bearings exceeding 366. But anyway, if you correct it using the proper adjustment, like your bearings cannot exceed 366, so that's why the actual bearings is positive 6.87, as we got using proper drawing, okay, more accurate. So those details are actually very significant for your exams, and however, I show you those details, and I hope you understand how it works, okay? So now you can see all the answers, and you might compare it with your guys, okay? So it's supposed to be like this. So anyway, if I adjust, we've got the right answers for each block. So you may compare. If you didn't get something, so just try to rewatch, because those details that appear here are very, very significant. Trust me. Okay? And the proper picture is right here on the right side. So hope you like that. Hope you understand those crucial details for your drawings, and hope you'll be accurately drawing your actually sketch so that to not get confused. If you still if you actually by accident you did it incorrectly or not accurately, you need to be able to adjust your bearings to the true one, which was actually 6 degrees, around approximately, instead of 366 as we actually got. All right, that was Daniel Dallas. That was a problem 2. Be waiting for the next problem 3, which is actually also interesting, taking into account what if the angle is not 90 degrees, what to do next. Okay, don't forget to subscribe if you're new here. Don't forget to smash the bell button to be notified about daily video that I created. Okay, see you later.